begin the floor and the roof, we need to first measure the cat. Here is Mama Izzo measuring the orzo. The idea for today looks pretty simple. Just a slab of wood for the floor, slab of wood for the roof, and we're done. Unfortunately, it's not that simple, particularly for the roof. The floor needs to be perpendicular to the frame, but not the roof. For the roof, Papa Izzo is going to need to shave off about 5 degrees. The reason he's going to need to shave off 5 degrees is so that when it is attached to the frame, it tilts 5 degrees. That will allow any rain and water to run off Here we have Papa Izzo cutting the floor down to size to make sure that it fits. Notice, after he makes any cut, he must sand it down to make sure orzo doesn't get any splinters in his paws. Papa Izzo is very against splinters. Here Papa Izzo is showing that he is adjusting the saw so that it is at a 5-degree angle. This is how he will cut the roof, but only the one side of the roof. After the cut, back to the sander. No splinters for orzo. For this side, when Papa Izzo cuts the roof, it is at 0 degrees, so the saw is perpendicular to the wood. Only that one side needs to be cut at a 5-degree angle. Finally, some more sanding, because we haven't seen enough of that. Okay, so if we take a look at our design, we have a beautiful box. Now, as we've talked about, the roof needs to be slanted. The roof needs to be slanted so that when it rains, poor orzo doesn't get wet, which means we can't have a rectangular prism. We need a trapezoidal prism, which means we need to build a roof on top of this. This is our basic sketch, and we're just going to build a roof, so we build up a little bit at that far end. If you remember, these were all parallel lines. We're going to construct another parallel line up there. Then we can connect it to our rectangular prism to make a nice trapezoid, or triangle plus rectangle, at the base. That would be the part that's facing towards us. Notice, those slanted sides for the roof are parallel to each other, but they're not parallel to anything else. Now, this is the roof. This is what's going to protect poor Orzo from the rain. This is how much we have to figure in to make sure that we actually have a slope. The angle we've chosen is 5 degrees. But why 5 degrees? Why not 10 degrees, 15 degrees, 50 degrees, 90 degrees? Why 5 degrees? Well, that is because of SOHCAHTOA and because of how much wood we have for the roof. This slab of wood for the roof is 25 inches. Now, it's really 26 and a half, but we want an inch and a half to overhang on the roof so that we don't finish the roof exactly. We have a little bit of an overhang system, just like all the roofs should, particularly in a place with much rain. This piece would then be how much do we have to account for between one vertical support and the next vertical support. We use our trigonometry, or SOHCAHTOA. In this case, we're using sine. So sine of 15 equals x over 25 inches. 25 was our hypotenuse, x is our opposite. 15 degrees would mean there has to be a 6.47 inch difference, which means the height at the end is actually going to be 6.5 inches shorter than the height at the window. So if my height at the window is 23 inches, that would make this 16.5 inches. That's a very drastic difference. And Orzo, he's a really tall cat, so we have to be extremely careful there. 16.5 inches, he's not going to be able to stand up on that end. So 15 degrees, not going to work. We have to figure out what will make it work. So we try 10 degrees, then we try 5 degrees, and we actually ended up with the 5-degree difference. 10 degrees would be okay, but 5 degrees was the best because that meant our x was only 2 inches, which means that we go from 23 inches at the window edge to about 20.8 inches at the other end, the part poking out of the window, which means 20 inches and about 13/16 of an inch. And that is how we calculate the uprights. We had to do all of this math, even though we're not ready to do the uprights. We have to calculate this to make sure how much we have to shave off to make the roof. And that was our 5-degree angle. We also needed to calculate this so that we could determine, once Orzo is in there, how big the bottom has to be. This bottom is now my adjacent side, which means we're using cosine. Cosine of 5 degrees, still using our hypotenuse as 25 inches, would give us 24.9 inches for the bottom. So, that bottom edge has to be cut so that it is 25 inches across. And the top needs to be cut so that it's 26.5 inches across if we want that overhang. And that is all of the math involved behind the scenes to figure out what the angle needed to be and what the dimensions needed to be for the roof and for the